Okay, so let me go ahead and give you the sheet that I have. We are going to be taking a look at some problem-solving strategies. Okay, so let's take a look at the first item here. So these are just some different ways. Say I have a problem, I'm trying to solve it. It's nice to have some different strategies on how I could make that and what makes sense. So take a look at the first question. The first question says, how many different ways can you make 25 cents using dimes, nickels, and pennies? So go ahead. Using a table makes a lot of sense here because I can sort of list out all my possibilities. So go ahead and see if you can figure out, come up with a couple of different ways and see if you can find a way. Maybe you can set yourself up with a pattern to make sure you find all of the ways. So I'll just start, if I only have dimes, nickels, and pennies, the most efficient, in my opinion, right? If I get to pick from anything, I would take 2 dimes and a nickel, right? And no pennies if I could. So there's one way that I could make 25 cents. Does that make sense? That's what you're doing. That sense, good. Get it? Pun intended. That, of course, is not my only way. Come up with some more. So I'm going to pull this off the screen. So you all can come up with yours and I'll come up with mine. And we'll see if we can find all the different ways.
So this whole chart is fillable?
Yep.
All right.
Oh, you may not use all the spaces. You might need more spaces. I don't know. So we just made boxes so you had just to help you organize it.
It should fill up the whole box.
You did fill up the whole box? Do you need more spaces?
$6. After I fill up this table, can I snap on this?
Sure. Okay, so let me hear. How many different ways did we come up with? Christian, how many did you come up with? Christian has 12. Give me some other answers. How many did other people come up with? You have 2? So we started, do you have the one with 2 dimes, 1 nickel, no pennies?
Yep.
And give me another way.
Okay, 0 dimes. Wait, actually. Dime is 10, right?
Yep.
Okay. So 2 dimes. Oh no, I can't do that.
You can. There is another way.
How many pennies can you use?
As many as you want.
Okay, so 15 pennies.
Well, that would be
5
1
pennies.
dime. If you did 1 dime and 15 pennies, that would work.
Yeah, that's what I meant.
But you could also do 2 dimes and how many pennies? 5. If you have 2 dimes, there's 20 cents and then 5 more pennies. Yeah. So, I agree with Christian. I came up with 12 also. Anybody get more than 12? Oh, anybody more than 12? So when you start filling out your chart, here's mine. So I'll show you how I came up with this. And I'll explain sort of where my pattern came from. So my first one, as you know, I was just thinking most efficient, right? If I have coins and I really have a ton of dimes, nickels, and pennies, and someone asks me for 25 cents, usually we're going to pick out 2 dimes and a nickel, right? Unless I have a quarter, right? If I had a quarter, I'd pick a quarter. But if I don't, I'm picking 2 dimes and a nickel. That's our most efficient. Okay? That's going to be using the least amount of coins. So then I said, okay, is there some way? This is how I did it. I asked myself, is there any other way to keep 2 dimes? If I keep 2 dimes, all right, well then I couldn't use a nickel at all because that would already get me up to 25 cents, but I could do no nickels and then do all pennies. So, and then I asked myself, are there any other ways that I could keep 2 dimes? Is there another combination that I could do? No, not with the limitations that we have. I only have these 3 types of coins. So these are my only 2 options if I'm going to have 2 dimes. So then I was like, okay, well now what if I only use 1 dime? Now I'm going to have some more combinations I could come up with. So you'll see the next bunch, I only use 1 dime. So if I use 1 dime, my most efficient would be to just use 3 nickels. I never really want to use pennies if I can avoid it. So 1 dime, 3 nickels. And then you can just work your way down this pattern. Okay, well, what if I only use 2 nickels? I'd have to use 5 pennies. If I only use 1 nickel, I'd have to use 10 pennies. And if I don't use any nickels at all, I'm left with 15. And now I've exhausted all the ways that I could use 1 dime. So now I say, well, do I have to use a dime at all? I don't have to. So let me get rid of using a dime altogether. And then my most efficient would be, okay, well, if I had 5 nickels, it would get me there. And then I could just work through this process. So using the chart, it's really nice because there's not like a set spot where you have to start or end, but it's a nice way to organize all of your thoughts. And then if you set it up in a table, you can start to look for patterns. And I can start to see, okay, well, what can I change? What can I alter here? So yeah, I'm out of options. It just so happened that we have as many boxes there ends up being combinations. So there are 12 ways. And there they all are. Does that make sense? So making a table is really nice for certain types of problems. Not every type of problem though. Some, I wouldn't want to use a chart at all because it just wouldn't make sense. If it was something like this, totally. Another thing that you would use a chart for that would be very convenient. Say you had 2 die, right? Like you know, a die with the dice, right? Singular is dice, plural is die. So if I said, well, show me all the rolls that you could make if you roll 2 dice, making a chart makes sense there. You can see them all, and then you could set up patterns and you could figure out all the different ways that all the different outcomes if you roll 2 dice. Okay, another way to solve a problem. Let's take a look at the middle one, using a formula. So these can be super useful. The formula for converting a temperature from Celsius to Fahrenheit. F is Fahrenheit is equal to 1.8 times whatever the measure is in Celsius plus 32. A lot of times people think you just add 32 because 0 degrees Celsius is the same as 32 degrees Fahrenheit. So they're like, oh, you just add 32. That only works at 0, right? That's because you're getting rid of that piece. When you go past that, you got to have this formula. So anywho, let's take that formula. And we're trying to figure out what 29 degrees Celsius would be in Fahrenheit. I'm going to recopy my formula over here. F equals 1.8 C plus 32. Okay, so the question is, what would 29 degrees Celsius be in Fahrenheit? Where do I put 29 in my formula? Yes, because it's in Celsius right now. So I'm going to be able to figure out the Fahrenheit temperature if I put a 29 in for C. Does that make sense? Right? They gave me the Celsius temperature, so I know what C is. Let's figure out what it is for F. So I'll grab my calculator. I got to do 1.8 times 29, and then I'm going to add 32 to it. So that temperature in Fahrenheit is 84.2 degrees. Sure. Okay, lastly, we are sketching a picture. This is one of your most useful methods.
I didn't have to go to that. I have to fill out water bottle.
Alrighty then. So sketching a picture, oh my gosh, I do this all the time. It says the perimeter of a rectangle is 20 inches. If 2 of the sides of the rectangle are each 6 inches, how long are the other 2 sides? And then they give me a formula for area. Okay, before we even go on, a rectangle. Let me draw myself a rectangle. How do you find perimeter? Bless you. What even is perimeter? Go back. What's perimeter of a rectangle? What is that?
You add sides.
Yeah, it's literally, if you were to walk along all of the edges, that's the perimeter, how far you walked all together.
And the area is just like times 2.
Yeah, well, it's times each side. So whatever the length of each side is, you would multiply with each other. So perimeter, you're just going to add all the sides. So they're telling me if you add all 4 of these sides together, it says that you're getting 20. It says in part A, if 2 of the sides of the rectangle are each 6 inches. So this is 6 and this is 6. The question is, well, how long are these? If I know that they all have to add up to be 20, my drawing might not be to scale, by the way. So if it looks longer than it should be, don't go off of how it looks. Just go off of the numbers.
Wouldn't it be 4 inches?
correct for each side, right? And another problem solving strategy that's not actually on here, you can guess, right? If you just guess and you were like, oh, okay, well, what if it was 5, right? So don't write this down, but what if I just made a guess that it was 5 and 5? If I add all that together, I get 11 plus 11, that's 22. So now I know, oops, that's a little bit too big. Let me guess another number. Let's try 4. And lo and behold, 4 really does work. There was an easier way to get this than guessing, but if you have no idea, try guessing, right? So here's what I would have done. You already have 6 and 6, that's 12. So let's take 12 away from 20. That means that these two sides together would have had to add to be 8. And if they're going to be the same, it only makes sense for it to be 4 and 4. Does that make sense? All right, so the other two sides must be 4 inches. So I'd say the other sides the other sides are 4 inches each. And let's take a look at part B. If the area of a rectangle is found using the formula, area equals base times height, find the area of the rectangle above. Okay, so I'm just going to recopy my rectangle down here. So I have one side is 6, one side is 4. And they're saying that the area is just base times height. You thought that was what?
Cube.
That's when you, that's volume. So if you do length, width times height, that gets you volume. Yeah. So if you just do base times height, what am I doing here? Exactly. I'm just going to do 6 times 4 or 4 times 6, right? Same thing. So I end up with 24. Does anybody know what the units are? Like we're in inches. Do you know how to write units for area?
Isn't it usually centimeters or inches, meters?
You're close. We're in inches, but since you did inches times inches, you actually end up with inches squared like that. You guys haven't taken geometry yet, right? Yeah, so you'll learn all that in geometry. Okay, so those are just some of our problem-solving strategies. Let me give you, let me see here, C block handouts. That's what I want. We're going to try and do a couple of these. And I'm going to walk you through some of them. Yes. We are not going to do all of them. But don't start yet. Oh my gosh. Okay, so we are actually, we're going to do the following ones. So make sure you circle them because I don't want you to do the wrong ones. We're going to do number 2, 6, and then 8, 9, 10.
So 6, what?
Yes, but I'm going to walk you through some of them. I'll put them up here. 2, 6, 7, 8. Oh, not 7. Sorry.
So 2, 6, 8 is
8, 9, 10. 2, 6, 8, 9, 10. Yep. 2, 6, 8, 9, 10. I'm going to do some of them with you right now. So you'll have even less. Let's try number 2 together. Okay, number 2 says, this is obviously a long time ago because it says gasoline costs $1.21 per gallon. Not anymore, but that's okay. Yeah, I know, right?
What happened to the first one? We're not doing it, she said.
We're going to do it tomorrow, but don't do it today. Gasoline costs $1.21 per gallon, tax included. Jamie paid $10.89 for the gasoline he put in his car. How many gallons of gasoline did he buy? Hunter, what do I even do?
$10?
Exactly. I'm going to take that $10.89 total and I'm going to divide it by $1.21 per gallon.
So that's like a 9 cents.
Yeah, so then I'm just going to grab my calculator. 9 it comes out to? Is it perfect? Or do we have to round? 9.
Oh, I got that. And I
That wasn't so bad. All right, let's jump down to 6. Ah, this is a good one for either making a chart or drawing a picture. So Mrs. Hernandez wants to put up a picture of each of her 3 grandchildren on the shelf above her desk. How many ways can she line up the pictures? May I recommend, instead of trying to draw 3 different people over and over and over again, can we just call them grandchild A, B, and C? So you could put, there's my pictures, right? There's picture A, B, and C. And then see if you can come up with some other way. How else could she do it if she wants to leave grandchild A in that same spot? Are there any other options? Correct. So she could have A and then switch C and B with each other. Are there any other options that have grandchild A coming first? No, that's it. That's all of them. But now, okay, let's say we don't have grandchild A in the first spot. So go ahead, see if you can draw out all the combinations, but be smart about it. You don't want to just randomly guess ones. You want some sort of a method so you make sure you find all of them. Yeah, so we could start with grandchild B now.
I think there's what? 9?
BCA would be one. And how else could you have B come first? You could have CBA. I'll put that in another spot.
ACB.
Yeah, no.
How else could I have grandchild B come first? BAC. And I think those are all the ways I have grandchild B coming first, right? And then I have grandchild C coming first that way. Is there any other way that C could come first? C, say again? AB. So now I stop and I ask myself, okay, every grandchild has now come first. Am I missing any other combinations? Is there any other way that I could have set these up following the parameters of the problem, right?
Oh, I said 6.
Yeah, so it looks like we came up with 6 different ways. Does everybody see a different thing we could have done? I know, right? We have every single possibility accounted for. So this one was a great one to draw a picture on. So yeah, I'd say 6 ways. Yep. Okay, we're going to jump to number 8. We used to buy CDs back in the day. Gunther paid for 6 CDs at a special 2-for-1 sale. The CDs that he got at the sale brought the total number of CDs in his collection of 42. How many CDs did he have before the sale?
Yeah, what?
So let's go back to the first sentence. It says Gunther paid for 6 CDs. So if he paid for 6 CDs during this sale, how many did he actually get? Connor? He would have gotten 12 because it's a buy one, get one free sale, right? So if he paid for 6, that means he got 12. So now they're saying, okay, now he has 42 altogether after he adds in his 12. So what did he have before this?
30.
I agree. Right? 30, Soup says, and I agree. So if he paid for 6, that means he got 12 because he's gonna buy 6 and get 6 for free. Buy 6, get 6 for free. So he got 12. So now when he comes home and he's bragging about how many CDs he has, and he's like, oh, I have 42 altogether. Right before he just bought all these, he must have had 30 because 42 minus the 12 he just bought gets us 30. Yep. Do we all agree? All right. I am not going to do 9 and 10 for you. So those are the only 2 that you guys have to do. I will, number 9, I would absolutely draw a picture for that.
Oh, that's easy.
It's not bad, but it's, if you draw it, it's so much easier to sort of wrap your mind around. Same thing with 10. I might draw that out. So let me go open this on Jupyter for you. One dash 5. Oh, I never ended the